We're going to look at these things called difference quotients next. And these are specific calculations that we end up doing in calculus. It's a very fundamental part of the first piece of calculus that you're going to learn. And it's the basis for one of the building blocks in calculus called a derivative. So you need to be able to evaluate a function in a way that creates this rational expression, and then you have to be able to simplify that expression. So they often end up being complex fractions, and that's kind of why it's a good idea to just practice with them now so that the algebra doesn't trip you up when you get to calculus. So for a function f of x, the difference quotient is this particular calculation. It's f of x plus h minus f of x all over h. So what you're going to do is you're going to plug x plus h into the function everywhere you see an x. And then you're going to subtract just f of x, which is the equation of the function itself. And you'll divide the whole thing by h. So let's give that a try in just a couple of places. And for each one of these, you'll see this function is already a fraction. So when I make this, it's going to be a complex fraction. So I'm going to construct and simplify the difference quotient. I'm going to start by writing down what a difference quotient is. And then I'm going to construct it for this particular function. So this function's rule tells me take 4 and divide it by whatever you're plugging into the function. So if I'm plugging in x plus h, I need to do 4 over x plus h. That would be f of x plus h in this case. And then minus f of x, which is just 4 over x. So that's just the original equation itself. And then the whole thing is over h. So this might look a little familiar to you because when we did complex fractions, we had an example that was very similar to this. Do you remember how we simplified these? When there was an addition or subtraction inside the complex fraction, we started by finding the LCD and then we multiplied the top and the bottom by that LCD. So in this case, our LCD would be x times x plus h. And so I'm going to multiply the top and the bottom by x times x plus h. When I distribute that here, the x plus h's will cancel. So I'll have x times 4. When I distribute that to here, the x's will cancel. So I'll have 4 times x plus h. And there is no denominator of the h. So these things are just going to be multiplied together. All right, remember our next step says construct and simplify. So when I have some adding and subtracting, I want to go ahead and distribute and combine terms. Leave the denominator factored. 4x minus 4x minus 4h. The 4x's are going to cancel each other out. I'm left with negative 4h. Oh, look, the h's will cancel here too, because once the x's cancel, then I just have one term on top. And so now I have simplified my difference quotient. So this isn't particularly new. I mean, the difference quotient part of it is a little bit new, calling it that. But we know how to plug things into a function, and we know how to simplify complex fractions. So I'm going to set up the second one just to get the first step going for you, and then I want you to keep trying. So our difference quotient here would be g of x plus h minus g of x all over h. So remember, that doesn't change. You're going to be plugging x plus h into this function. So there are now 2 places to plug it in. Everywhere I see an x, I'm going to replace it with x plus h. So that would be x plus h over x plus h plus 2. Then I'm going to subtract g of x, which is just the original equation of this function, and divide the whole thing by h. All right, we've constructed our complex fraction, and now I'm going to look at my denominators and try to find my LCD. But since I can't factor either of those, my LCD is going to be this kind of long x plus h plus 2 times x plus 2 all over x plus h plus 2 times x plus 2. All right, so go ahead and pause here and keep simplifying. How did it go? Yeah, it's a lot of work, right? So when I am distributing here, these will cancel, and I'll have x plus h times x plus 2. When I'm distributing here, the x plus 2's will cancel, so I'll be left with minus x times x plus h plus 2. And then everything just multiplied together on the bottom, which I'm going to leave factored. So then I FOILed this out and distributed my negative x. A whole bunch of things canceled, and I was left with just 2h on the top, which allowed me to cancel the h's. Spoiler alert, the h always cancels. And then I was left with just 2 over the remaining 2 factors in the denominator.